Today we're going to move over to chapter 11. We are going to cover the law of sines. How do you use trigonometry to solve and find the areas of oblique triangles. So we're going to solve oblique triangles and we're also going to find the area. So take the time to write the title, your essential question. And if you had Algebra 2 honors last year, then you covered this before. And if you did not have honors last year, then this is going to be the first time that you cover it. So go and take the time to copy everything down and then we'll start. Go and pause it and then we'll start once you're ready. Excellent. So we're actually going to go through a proof. I know that we don't prove some of the problems or some of the formulas that we use. We are going to prove the one that takes a little less time and a little more easy to understand. So the proof for the law of sines. So we have triangle ABC. ABC is an oblique triangle because it has no right triangle or no right angle. So A, B, and C, neither of those three are right angles. So therefore, since it's not a right triangle, we cannot use SOHCAHTOA. So all of the previous trick that we have learned cannot be used in here. So SOHCAHTOA, Pythagorean theorem cannot be used here. So therefore, we have angle A, and for angle B, what we're going to do first, we are going to draw a line from point C. We are going to draw a line perpendicular to the base, which will make this line a altitude or the height. So we're going to call that H. And we are going to use this triangle on the left hand side. And we are using the law of sine, so therefore we're going to find the sine for angle A. So the sine for angle A will be the sine, if you guys remember, your sine will be your opposite over hypotenuse. Now we can use SOHCAHTOA, opposite over hypotenuse, because this is a right angle, therefore the yellow triangle is a right triangle. So it'll be the opposite over your hypotenuse. And now we're going to do the same thing for angle B. And we're going to be using this triangle on the right hand side. It's also a right triangle, so therefore we can use SOHCAHTOA. So for angle B, sine is your opposite over hypotenuse. So therefore the sine of B will be the opposite, which is H, over hypotenuse, which is A. Now what we want to do, we want to be able to leave the H by itself. So therefore on this side, I'm going to multiply both sides by B. And therefore my b's cancel. And H is equal to B, the sine of A. And on this side, I'm going to do the same thing. I need to be able to leave the H by itself. So therefore I'm going to multiply both sides by A. By multiplying by A, my H is by itself. So therefore H equals A, the sine of B. And let me just get rid of this. Anyways, that'll be with us for a while. That did not help. Give me a second. Okay, so just ignore this for now. So therefore, let's see, the heights. So now, since they both are equal to h, therefore they must be equal to each other. So we can place b sine of a must be equal to a sine of b, since they both are equal to h. Now I can have I'm going to leave the b on the numerator, so actually the sine on the numerator. So I'm going to divide both sides by, actually I'm going to sine of a on both sides. So I'm going to divide by sine of a on both sides, so therefore we have b equals a sine of b over the sine of a. I need to be able to get rid of the sine of b on this side, so therefore I'm going to multiply by the reciprocal, 1 sine of b, 1 over the sine of b, 1 over the sine of b. So therefore the sine of b will cancel out, and I have b over the sine of b is equal to a the sine of a. And therefore we have this section here that we proved. So a sine of a is equal to b sine of b. Now we can go through the same process and prove that a sine of a is equal to c sine of c. Do you guys want to go through a process? Correct. And the same thing here. We can actually prove b sine of b is equal to c sine of c by just going through the same process, but not making your altitude going over this way, or your altitude coming down to this base. But the process will be exactly the same. So at this point you should have your cutout. If not, just make space for it, or you can go and draw it and just copy it over. So if angle AB and C is a triangle with sides A, B, and C, notice that it doesn't say that it's an oblique triangle. So it also works with a right triangle. But in this case, most of the time, if it's a right triangle, we actually just use SOHCAHTOA. And it works whether the angle is an acute angle or whether it's an obtuse angle. And notice that we can also have the reciprocal. We can have the angle sine of A over side A equals sine of angle B over side B, and so on. But for now, let's go through example number 1. Go ahead and take the time to copy it down, and then we'll continue. Go and pause it if you need to. So for a triangle, angle C is 102.3 degrees, angle B is 28.7, and we have side B that's 27.4. So we're going to do two things. We're going to draw a quick triangle. And let's see, we have side B is 28.7. So this will be angle B. We'll have angle A here, and we'll place angle C on top. So it's 28, so that's 20. I just want to make sure that I get to a vertex. And notice that's going to be hard to kind of draw on scale, especially because we're not too sure of the other sides. So in this case, I decided that this was going to be angle B, which is 28.7. Angle C is 102.3 degrees. We're looking for angle A. And side B is opposite angle B, so therefore this is 27.4. Now, one of the things that you want to notice is that in order for you to use the law of sines, you must have a side and the opposite angle in order for you to be able to use the law of sines. So this visually you guys can see it. So we're going to do 27.4 over the sine of B, and then we can look for angle or side C. But also, since we need to find the remaining angles and sides, we want to make sure that we label. So we need to make sure that we have angle A, angle B, and angle C. And in this case, we know that angle C is 102.3 degrees. Angle B is 28.7 degrees. We know that angle side A, side B, and side C. Side B is 27.4 feet. So let's see, what do you guys want to find first? What will be the easiest? Correct, we should go to find angle A first. So I know that all three angles in a triangle are equals to 180 degrees. So 180 minus 28.7 minus 102.3, that will give us 49 degrees. So therefore angle A is 49 degrees. So we have all three angles. So let's go and find side A first, and then we'll come back to side C. So find A. So I know that side A over the sine of angle A, which is 49 degrees, is going to be equal to side B, which is 27.4 over the sine of the angle, 28.7 degrees. And let me not forget my degrees. Remember that you do need to be able to place your degrees, otherwise that'll be the sine of 49 radians. I need to be able to leave the A by itself, so therefore I'm going to multiply both sides by the sine of 49 degrees. And some of you guys actually just do it one step. We know that cancels, so therefore A equals 27.4 times the sine of 49 degrees over the sine of 28.7 degrees. Now, if they want an exact answer, this will be your answer. For purposes today, we do need an approximation. So therefore, A is approximately, and I'm going to use my calculator. Now, by any chance, if you do not have a calculator at home, one of the things that you can use, you can use the Desmos scientific calculator, which is this one here. And what's nice is that this is the calculator that you guys will be using on your SPAC. So therefore I can use my fraction bar and I can type everything. You have sine, cosine. Make sure that you are on degrees, not radians. So you're on degrees. But for now, let me just go and type in, I'm going to use my fraction bar. And it's on degrees, which is perfect. And if I can type it in correctly, I'll be 43.1. It'll be 43.1 feet. And let me go and label up here. Now, go and find C, and then we can compare our answers. Go and pause it, find C, and see what you get. Excellent. So at this point, you should have found C over the sine of C, which is 102.3 degrees. It's going to be equals side B, 27.4, over the sine of angle B, which is 28.7 degrees. I'm going to go through the same process. I'm going to go multiply both sides by the sine of 102.3. So that gives me C is equal to 27.4 the sine of 102.3 degrees over the sine of 28.7 degrees. If they want an exact answer, this will be an exact answer. Approximation. Now remember that in order to get this, I multiply both sides by the sine of 102.3 degrees. That cancels, and it's here. So another thing that you notice is that your setup is almost the same as above, so I can just go back. On your TI-84, you can just do second entry, and that will bring this notation. Everything else is exactly the same, so therefore that'll be 55.7, and that'll be feet. But one of the key things they need to remember is that whenever you are using your law of sines, you must have an angle and the opposite side. Example number 2. Go and copy it down, pause it if you need to, or you can use the cutout that you have online. So a pole tilts towards the sun at an angle of 8 degrees. So the pole is tilting at an angle of 8 degrees from the vertical. And it casts a shadow, a 22-foot shadow. The angle of elevation from the tip of the shadow to the top of the pole is 43. Now remember that whenever they give you the angle of elevations from the ground up, that's 43 degrees. How tall is the pole? Now we are very tempted to use SOHCAHTOA, but this is no longer a right triangle. So we can now use opposite over hypotenuse or opposite over adjacent. That's only valid if it's a right triangle. So therefore, I have a side. So therefore, I need to be able to find the opposite angle in order to be able to use the law of sines. And we have enough information to find the missing angle. So do me a huge favor, go and find the missing angle, find C, and see what you get. And then we can compare our answers. Correct, so side angle C, I know that it's going to be 180 degrees minus 43 minus, what is this angle? That'll be 98. So angle C is equal 39 degrees. So now that I know that this is 39 degrees, we can use the law of sines to be able to find side A. So go and find side A, and then we can compare our answer. Go and pause it. Correct. So in this case, we have A over the sine of A, which is 43 degrees, is equal to C, which is 22 feet, over the sine of angle C, which is 39 degrees. I'm going to multiply both sides by the sine of 43, so therefore A equals 22, the sine of 43 degrees, over the sine of 39 degrees. Now, if they want an exact answer, this will be your exact answer. And if they want an approximation, we can just step into the calculator. It will give us, let me use my fraction bar, 22 sine of 43 over the sine of 39. And therefore, A is approximately 23.8. And they're not using any decimal places, but for purposes, we're just going to use 23.8 or 28 feet is fine. So therefore, the law of sines will allow us to be able to find the angle or the side of a right triangle. Notice that right now the only thing that we find is the actual sides. So let's go through example number 3. Go ahead and write it down, and then we can start once you are ready. So for a triangle, angle A is 78.3 degrees, side A is 7.7 inches, and side B is 35 inches. Find the remaining angle in sides. So therefore, we have, let's go and make a triangle. Angle is 78. So this is 78, should be around here. So I'll place it up there. And side A is 7. I'm going to place this is angle A. So therefore side A will be 7 inches. And this will be side B. And that'll be angle B. So therefore this will be 35 inches. Now notice that it's really hard to make it to scale. So for now, it should be fine. And we have angle A, angle B, angle C, side A, side B, side C. So we have 78.3. A will be 7 inches and B will be 35 inches. So therefore we have a side and the opposite angle. So therefore we are able to use the law of sines. Remember that you're only able to use the law of sines if you have a side and the opposite angle. So therefore, since we have side B, we're going to find angle B first. So find B. So we have 7. So actually, let's look for sine B over 35 equals, I'm using sine first, so that'll be the sine of angle 78.3 degrees over 7. I'll multiply both sides by the 35, so that will give me the sine of B is equal to 35 sine of 78.3 degrees over 7. I'm going to type into the calculator. So therefore the sine of B is equal to, and we have, once again I'm going to use my fraction part, 35 multiplied by the sine of 78.3 over 7. And that gives me 4.9, 4.89. And I'm going to take the inverse sine, make sure that I'm on degrees, inverse sine of my answer, and make sure that you guys use your answer rather than using 4.89, so you guys get a more exact answer. And let's see, 3578.3 divided by 7. You don't make a mistake. Do you guys catch my mistake? So what is my mistake in this case? Did you get an error as well? Correct, so we get an error. So can you guys think about why am I getting an error? Correct. So notice that in this case, we're looking for the sine of an angle who's 4.89. And remember that your sine goes up to 1, down to -1, up to 1, down to -1. So the sine of an angle cannot be greater than 1. It can be 1, but nothing bigger. So therefore, this triangle is not possible. So not all triangles will be possible. And that will take us to, and we'll come back to this in a second. That will take us to the cutout. So you want to make sure that you print it out, or you can just take the time to copy it down. Let me zoom out. So we have an ambiguous case when we're dealing with side-side angle. So every time that you're looking for an angle and you are looking for the law of sines, you might end up with an extraneous solution. So one of the things that you must find is you want to be able to find the height using the following formula, which is we use at the beginning of the lesson. So if you have an acute angle A, if the side A is shorter, is less than the actual height, then you have no triangle. Let me see if I can illustrate that for you guys. Let's see. There we go. So ignore this. So assume that this is the height. Let me move it to this way. So we have if the height, this is your height and this is your side. If the side happens to be smaller, so let's say we have the height. If it happens to be behaving, here we go. If the height happens to be smaller, if your side happens to be smaller than your height, then if we rotate it, notice that it's not going to reach your triangle. So it doesn't matter how much you rotate, if your side is smaller than your height, then there's no way that's going to reach down to the other side. Do you guys agree? Even if it's almost there, notice that it's almost going to reach, but not there. In order for it to be a right triangle with the measurements that they give you, your height has to be at least exactly the same. If it happens to be exactly the same, then you end up with one triangle, which is your second case. So your second case, this is a case where your height will be equal to the side. Then you have one triangle, and the triangle happens to be a right triangle. Now in the third case, where you still have one triangle, if your A is bigger than the B. So let's go move it over here, and let me see if I can make that bigger. Once I have it bigger, then you can have one triangle, and your triangle will be formed over there. It doesn't reach. Let me just make that a little higher. There you go. So if your side is just bigger, whether it's slightly bigger, then the only way that you're going to have a triangle will be right over here. That'll be your triangle. Now, on the third case, or actually on the fourth case, the way that you end up with two triangles is whenever your side is smaller than B, but it's larger than your height, correct? But it's smaller than B. Then you have two triangles. We have this triangle here, which is this smaller triangle here, or you can have it where it actually can be on this side and you have your other triangle. So you have two different cases, and that's going to be only whenever your side B is either it's shorter than your side A is shorter than your side B, but it's longer than your height. Because if it's smaller than your height, then it doesn't reach. It doesn't matter that it's shorter than B, it's going to be shorter than your side, so that doesn't reach. So the only time is whenever it's between, it's greater than your height, but smaller than B. We're going to have two triangles. That's one, and that'll be the other. So let's go back to the notes. So this case here is illustrated when we have it one triangle's here and the other one's here. This case is illustrated whenever, so this case is whenever your side A is bigger than B, it's not going to form a triangle over here. The only triangle that's able to form is right over here, and that'll be your triangle. The second option, whenever A and H are equal, that will be that it barely reaches, they're equal to each other, just slightly bigger, but I guess no way. Whenever it's exactly the same, it's going to be a right triangle. But whenever it's smaller than your height, it's not going to make a triangle because it's not able to reach down there. And that is the first case. So hopefully that helped you kind of understand your ambiguous case. And the same thing whenever you have a obtuse triangle. If A is smaller than B, which also will be smaller than your, so in this case, yeah, it doesn't, but you guys see the picture. So let's go through example, or let's go back to example number 3. On example number 3, so one of the things that you wanted to do every single time, you wanted to be able to find the height. So the height will be equal to A, sorry, B sine of A. So B, the sine of A, which is 78.3. So the height is equal to B, 35, and the sine of A, which is 78.3. And I'm going to type into the calculator. That gives me 34. So H is approximately 34.3. In this case, A is 7. So therefore, A is smaller than H. Therefore, there's no triangle. There's no such triangle that will be that will exist. So let's go over to example number 4. So in that case, your side was too small for it to reach the ground. Example number 4. So for a triangle, side A is 12, side B is 31, angle A is 20.5. So I'm just gonna make a quick drawing so I can actually see it. I'm looking for 20 degrees, so it's 40, so it's going to be now in this case you have no idea if you're doing actually a correct drawing. I'm just going to start with 20.5 degrees. This is angle A, this is 12. I'm going to place side B here and side C, so therefore this is 31. Before I start, what I want to do, I want to be able to find my height. And to find the height, we're going to use the same formula, the one that we developed from the very beginning. So H is equal to B sine of A. Now be careful. Sometimes they actually start with side B, side C, and angle C. So you might have to switch the letters to correspond to this formula here. And we'll do that on the next example. So we have H is equal to 31 with a sine of 20.5 degrees. I'm going to use my calculator just to be able to calculate this. So 31 sine of 20.5, so it'll be 10.9. So H is approximately 10.9. We know the side A is 12. So therefore, will it reach, so if this is 12 and this is 10.9, is it going to reach the ground? Yes. So therefore it's going to reach here, but it's also going to reach over here since it's smaller than side B. So therefore there are two triangles. So the height is smaller than A, which is smaller than B. Since H is 10.9, A is 12, and B is 31. So therefore, if you rotate it, this will be here. It's going to be bigger than your height, and there'll be another triangle that you're going to be able to form. So therefore, you have two triangles. But let's go through a process. We have, let's assume that we didn't know this. In this case, we have angle A, angle B, angle C. We have side A, side B, and side C. This is 20.5 degrees. This is 12 units. This is 31 units. So we have a side and an angle. So therefore we're going to be able to find angle B first. Let's make sure you write small. We're going to need the space. So we're going to find angle B. So the sine of B over 31 is equal to the sine of A, which is 22.5 over 12. Multiply both sides by 31, so therefore the sine of B is equal to 31, the sine of 20.5 degrees over 12. I'm going to type into the calculator. Now remember that in this case, if you get a number bigger than 1 or less than -1, then you know that you're going to have no triangles. So that'll be a clue that you have no triangles. In this case, I show you. So you have 0.9. So therefore, we do have a triangle. And it's going to be x is equal to 0.9. So angle B. Now remember that you want to be able to write this down. You don't want to just take the inverse right away. So but you will take the inverse sign of your answer to have a more exact answer. And that will give you 64.8. So approximately 64.8 degrees. Now this, remember that you're going to end up with two triangles. So therefore this will be B1. So this will be A1, B1, C1. And because we have two triangles, we're going to end up with A2, B2, C2. So the same original information that they give you applies to both triangles. Angle B is B1 is 64.8 degrees. Now, how can I find B2? Now remember that when you calculate, when you are using the inverse, it will only give you angles on so sine is going to give you from negative 90 or from negative pi over 2 to positive pi over 2, or in this case from negative 90 degrees to positive 90 degrees. In this case gives you 64.8 degrees. So I know that 64.8 degrees is around here, maybe a little larger. So this is 64.8. Where is the other angle whose sine value is going to be the same? Can you find it? Go and pause it, find it, and see what we get. Correct. The other angle will be over here. So how can I find that? So therefore, you always, to be able to find your other angle, B2, it will always be 180 degrees minus 64.8. But most of the time we do it logically, just like we've done before. And that gives me 180 minus 64.8. But you can always just do 180 minus, since we are always using the law of sine. And that gives me 115.2 degrees. So therefore, this is 115.2 degrees. So therefore, I can find C1, 180 minus 20.5 minus 64.8. That gives me 94.7. Let me find C2, 180 minus 20.5 minus 115.2. That'll be 44.3. And now I can find C1, and then I can find C2. Now some of you guys are very tempted to use Pythagorean theorem, but remember that this is not a right triangle, so we can no longer use Pythagorean theorem. So therefore I use the law of sines again to find C1. So C1 is equal to the sine of C1, which is 94.7. Find it, see what you get. It's equal to, we have 12 over the sine of 20.5 degrees. So therefore C is equal to 12 sine of 94.7 degrees over the sine of 20.5 degrees. Now remember that this is an exact value, and even if it was actually, most of the time we actually want to keep over 94.7, the exact value for that, so we don't round it up as much. But for our purposes today, this should be fine. Most of the time, if they give you a whole numbers, they actually just expect a full whole number, so 34 should be fine. Now I'm gonna find C2. See what you get for C2. So I can just go and use what I had before. So therefore C2 is approximately 23.9, or in this case we're going to say 24. So therefore we do have two triangles. And you want to make sure that you give the information for both. Let's go to the last example for today. Well, actually we have one more after this. Example number 5. So hang in there. I know this is a longer notes than usual. The next ones will be much shorter, or just a little bit shorter. Go ahead and copy it down, and then we can go through the process. So for a triangle with side B, angle or side A, and angle A is 42. Now be careful. Sometimes they might say that this is angle C or side C, this is side B, and this is angle B. So if that's the case, I usually just switch them around to A, just so I can actually go through the formulas. But for now, this is given to me in the correct form. Or just not the correct form, but I will say the easier form. So I'm going to draw a triangle just to illustrate the process. 42 degrees, so this is 45. So assume that's almost 45. So this is 42 degrees, that's side A. So therefore this is 22 and this is 12. So therefore this is angle B and that's side angle C. So therefore I'm going to find the height to determine whether we do have a triangle or not. In this case, if you notice, we should have at least one triangle just by looking at it. So that's the nice thing, that actually if you actually take the time to make a triangle in more accurate angle 42, even though these ones are different, if you notice this is 12, so therefore if this is 22 you probably have to open it up much more. So it's almost the twice length. So in this case we're going to find the height, h equal to b sine of a, where b is 12 and the sine of a is 42 degrees. I'm going to type into the calculator. We have 2, the sine of 42. That gives me 8. H is equal to 8. So in this case, this will actually get to reach the height. So I know that we have one triangle. The question is, do we have two triangles? So in this case, if you rotate it, it's not going to be able to make another triangle in this section here because it's going to be longer than 12. So therefore we only have one triangle. But let's assume that you actually did not know that whether you have one triangle or not. So let's go through and just label A, B, C, side A, side B, side C. So this is 42 degrees. This is 22 inches. B is 12 inches. Once again, in order to use the law of sines, you must have an angle in your opposite side. And we do. So the first thing that we're going to do, we're going to find angle B. So therefore, it will be the sine of B over B, which is 12, equals the sine of 42 degrees over 22. I'm going to multiply both sides by 12. So that gives me the sine of B is equal to 12 plus sine of 42 degrees over 22. I'm not going to type that into the calculator. And I have my fraction bar, 12 sine of 42 over, so be the sine of B is equal to, or approximately, 0.36. So therefore angle B is approximately, I'm going to find the sine of my answer, so it'll be 21.4 degrees. So therefore, what will be my other angle? So this will be angle 1. So let's assume that we don't know whether it has one triangle or not. Let's assume that we forgot to figure out whether we have one or two. So this is my first triangle. And my second triangle, where the given information is the same. So this was 21.4. How do we find the second angle? It will be 180 minus 21.4. And remember why? Because it's going to give us on the first quadrant or the fourth. So this case gives 21.4. So therefore the second one will be over here. So it'll be 180 minus that angle. So B2 will be 158.6 degrees. And now we can find the angle, so it'll be 180 minus 21.4 minus, let's do 180 minus 21.4 minus 42. It'll be 116.6 degrees. Now if we try to find the other angle, it will be 180 minus 42 minus 158.6. It will give us a negative degree. And that should be a clue that it doesn't exist. Those two angles are already greater than 180. So therefore there's no more space for the third one. So therefore there's only one triangle. And you can find that information sooner if you actually can think about this process first. Otherwise, you'll get an error here and you can't catch afterwards. So the only thing that I need to be able to find is C1. So therefore, to be able to find C1, I'm going to use the law of sines. So use the law of sines, see what you get for C1. So that's it. C1 over the sine of 116.6 degrees. Remember to place your degree signs. We have 22 over the sine of 42 degrees. Multiply by the sine of 116 degrees on both sides. I can type that into the calculator. So therefore C1 is equal to 29.4. They don't give you any decimal, so you probably sometimes end up with 29. But in this case, I'm just going to say 29.4 inches. On your homework, I'll tell you how many decimal places you need. And the last example for today. But actually, before we get to the last example, let's go through and develop the formula for the area. Now, those formulas are essential for your SATs. So what we're going to do, to be able to find the height, if you guys remember, if you guys remember, what is your formula for the area of a triangle? Is equal to 1/2 base times height. But now instead of the height, the base is, in this case, is letter C. So you just have to be careful. In this case, we have 1/2 where the base is C. In the height, we are going to use this here, which is B sine of A. So therefore, area is equal to 1/2 BC sine of A. And that's how the formula is developed. But you do need to be able to memorize, because this one's come very handy whenever you guys are taking your SAT. So I've seen many questions that they expect you to know this formula for the area of a triangle. So the area is 1/2, you should know that, and it's 2 sides in the sine of the opposite angle, or the third angle, BC sine of A, or AC sine of B, or AB sine of C. Find the area of a triangular lot having 2 sides, 90. So let's go and make a quick drawing. So it's actually nice to be able to see. For me, I'm a more visual person. So if I know, can visualize, then I'll have to, it's easy for me to remember. So we have A, B, and C. And find the area of a triangular lot having 2 sides length 90 and 42 in the included angle. So 90 and 52 in the angle in between is 102 degrees. Now, therefore, in order to be able to use these formulas, you need to have 2 sides in the angle in between. So therefore, if I can visualize that, I know that's going to be 1/2 90 52 in the sine of the angle between, which is 102. It's just a very quick calculation, and this is very useful sometimes whenever you don't have the height. You can calculate the height and come up with the height if you need to. But in this case, this is 90 times 52 times the sine of 102 degrees, which is, the area is approximately 2288. And they don't give me any decimal places, so I'm just going to give them more. And this will be in meters squared. Remember that this formula you do need, in order to go to reach a high score in your SATs, this will be one of the formulas that you guys will need to remember. So those are the notes for today. Have a great day, and send me an email if you have any questions. I'll see you guys next time.